Okay, this section 3.4 is about equivalent statements. If you read the beginning here, it says, consider the following statements. If you get straight A's, then you are on the president's list. If you're on the president's list, then you get straight A's. If you did not get straight A's, then you are not on the president's list. If you're not on the president's list, then you did not get straight A's. All of these statements are saying the same thing, or does each one say something completely different from the others? In this section, we will use logical symbols and truth tables to compare each of these statements. We will also learn several forms of equivalent statements. All right, so here's the definition of an equivalent statement. Two statements are equivalent, symbolized by this two-line double arrow pointing in both directions. And make sure you understand that this is different from the if-then statement. The if-then statement just has one line and one arrow. Okay? And both statements are exactly the same truth values in the answer columns of the truth tables. So sometimes the words logically equivalent are used in place of the words equivalent. Okay, so equivalent statements. Let's look at this. This is example 1. It says P and Q or R. And then it says P and Q or P and R. All right. So if we look at these, the first thing we do is we get P, which we get from just the tables in the beginning. These are pretty standard. Q we get and R we get. Then we deal with P, so we transfer all these values for P over to here. We look at Q and or R. Of course, true is true, false is true, false true is true. You can look at these tables at the beginning of this chapter and see and get these values. And then we see that true is true, true, false. The rest of them are false because they have a false in there because we're dealing with and. Remember, when we deal with and, they must either be true. Here, P and Q is, we can get that from a truth table that's in the beginning. P and R, we can also get it. And then we get the two of these from true is true, false is true, false true is true, false because it's or. Remember, all that has to, when it's or, is one of them has to be true. So these are false. So if we look at these truth values in the pink, we'll see that these are the same as these. So these are called equivalent, logically equivalent. If we look at this is example 2. It says determine whether the following statements are equivalent. If you win your fantasy football league and you are here Friday, then you will celebrate. If you do not win your fantasy football league or you are not here Friday, then you will not celebrate. So here's our P is you win your fantasy football league, Q is you are here Friday, R is you will celebrate. So we come over here and we do our truth table. Here's B, which says P and Q if and then R, or biconditional R. This one says negated P or negated Q, biconditional negated R. And so again, we go through the truth tables. And again, these right here are standard. They're at the beginning. These values you don't have to look up or anything. You should just go to the table and get them. Same with this one, and same with these, because these are the opposite of these. So you can see right here, true for P and true for Q is false. What we find out is these are equivalent statements because when we finish, this statement here is equivalent to this statement here. All right. De Morgan's law for logic says that a negated outside parentheses for P and Q is equivalent, logically equivalent, to negated P or negated Q. A negated parentheses P or Q is logically equivalent to negated P and negated Q. So this is something that you can always look at, because if you get something that says negated outside of parentheses, and then here if you get this statement, then you know that they're logically equivalent. On De Morgan's law, if you look at this, it says select the statements that is logically equivalent to I do not have investments, but I do have debts. All right, so A says I do not have investments, or I do not have debts. Okay. B says it is false that I have investments and I have debts. C is it is false that I have investments or I have debts. Last one, I have investments or I have debts. So what happens here is this, is if we look at these, right? The statement, I do not have investments, but I do have debts, written symbolically, is negated P and negated Q. Recall that the word but means the same thing as and. Now, write parts through A through D. So we have negated P or negated Q, which is not the equivalent. We have negated P and Q. So let's go back up here. With us having negated P and Q, it should be equal to negated P and Q or. And so if we look at these right here we have and, negated, and we have the negated outside. So, here this is true. If we look at these by De Morgan's law, no, and these, yes. So if we look at this, it says De Morgan's law shows that negated P and negated Q is equivalent to negated P, parentheses P and Q. Therefore, the answer is C. Okay, so it was right here.